Hi everyone, we are going to look at 212 and 213. 212 dealt with our rules of logarithms, so expanding logarithms or condensing logarithms, and then 213 is looking at solving exponential or logarithmic equations, and we might have to use our log rules to be able to solve equations. So let's look at a couple examples together just to kind of remind ourselves how to do this and refresh our memory. So at the top here, I'm going to do the one on the left. And it asks us to expand the following expressions. So I notice that I'm taking the natural log of a term that has multiplication on the inside. And so when I expand that out, it'll turn into addition between my terms. So for this first one, I can rewrite this as natural log of x. That's the first term in this. Then I'm going to add natural log of my second term, which is y to the power of 4. And then I'm going to add another natural log of z to the power of 7. I can expand this further because all of my exponents can move down as coefficients. So this 4 will come down in front, and this 7 will also come down in front. So expanded fully, it'll look like natural log of x plus 4 natural log of y plus 7 natural log of z. And that would end up being my final answer. You can try the one on the right, and I do have the key posted for this one. And I'm gonna skip the practice problems underneath. I want you to try those on your own and then check your work with the key that is posted, but I want to go through some examples on the bottom for 213. So these two just ask us to describe the first step. To solve, it doesn't actually ask us to solve it. So I am going to solve it, and I'm going to talk about the first step and what I notice, and then we'll look at a couple more on the back of this paper. So the first thing I notice is this is an exponential equation. And I know it's exponential because my exponent, or my exponent here has my variable in it, or my variable is in my exponent. So because it's exponential, I know that I'm going to have to use logarithms to solve this. The first thing I want to do is I want to make sure that the base that has my exponent, so the base that has my exponent is the 5, is already isolated. And this one is. I don't have anything out in front here being multiplied or added on. I don't have anything after my exponent like here. And so it's already isolated. I can move on to step 2. For step 2, I want to take the log or natural log of both sides. So if I were to describe my first step, I am going to make a little note here. We need to take log or natural log of both sides. If I had to isolate that 5 with the exponent first, that would be my first step. But since it's already isolated, this is my first step. So I'm going to show this. I am going to do log of the left and log of the right. Now that I have the log shown, I can bring down my exponent as a coefficient. So when I rewrite it, now that's a coefficient. And my equation looks something like this. One thing that we do have to remember is anytime we have log of something, this is one term. This is technically just a number. Same thing here. This is just a number. We could type that into our calculator and get the decimal form for it. But I'm going to do this as if I don't have a calculator first, and then I will figure out my decimal equivalent. So if I want to get x by itself, I'm trying to move away everything from my variable. So I want to get rid of my log 5. And it is being multiplied by my parentheses, so I'm going to divide both sides by log 5. What I have left is x plus 2 equals log of 4 over log 5. Then to get x by itself, I'm just going to subtract 2 from both sides, and I'll tack that minus 2 on the outside of that fraction. So my non-calculator answer will look something like this. X equals log 4 divided by log 5 with a minus 2 on the outside. So this is my non-calculator answer. If I find my calculator equivalent, I always want to round to 3 decimal places, and that ends up giving me negative 1.139. So this question did not decipher between if it's calculator or non-calculator, so I wanted to show you both. Let's just talk about the one on the right here. So it does say you do, but it says log base 5 of my argument equals 2. And so this is actually different from the one I did because it's not an exponential equation. It is a logarithmic equation because we see the log in our equation. So that means I have to use my exponent rules or exponential thinking to solve this. And there's 2 ways we can approach this. One way is I can convert this into exponential form. So I still want to make sure my log part is isolated, and it is. I'm doing log base 5 of the 2x plus 1. There's nothing on the outside that I need to move to make it isolated. So I'm going to use my cloud method and rewrite this in exponential form. So I would do 5 squared, 5 squared equals my argument of 2x plus 1. So when I rewrite that, I have 5 squared equals 2x plus 1. Well, I know 5 squared is 25, so I'm going to rewrite that. And now this is a normal linear equation. I can solve for x. I'm going to subtract 1 on both sides. So I get 24 equals 2x. Divide both sides by 2, and I get x equals 12. Let's do one more on the back here. So on the back side, I'm going to do one more log equation to solve. So the top left one says log of 3x plus 1 equals 2, and it says solve the following equations. So the other way that we can do this, if we did not want to do the cloud method or forgot the cloud method, where I would do the base to the power of 2 equals my argument, maybe I forget how to do that. My invisible base on this one is 10. So if it would be helpful to write that in, I can write that in. Since my base is 10, I could, on each side, have a base of 10 and then raise everything as an exponent. So my 2 from here would be an exponent on my 10, and then all of this would also be an exponent on this 10. And it would look something like this. Now, because I have a base of 10 and a base of 10 on the log, that part gets canceled out, and I'm left with 3x plus 1 equals 10 squared. Well, 10 squared is 100, so 3x plus 1 equals 100. I'm kind of running out of room, so I'm not going to show all my work. I subtract 1 on both sides, so we get 3x equals 99. Which means x equals 33. So hopefully that's a good little refresher for you for a little bit of 212 and a little bit of 213.